Hello class, this is Mr. Hart, and in this podcast we want to start talking about how we calculate the current in a circuit. Okay, and again, this is kind of the most important piece of designing a good current because, as we talked about last time, you don't want the current to flow too fast, you don't want it to flow too slow, and you want to make it something that will be able to run effectively on the devices that you're using. Okay, so current is a huge factor, especially for anyone that's designing electrical devices. Okay. So the main governing equation of the current, what it actually means, can be represented like this. Okay, so current, okay, we represent it with an I in electricity. Okay, we're talking about electrical physics. So current is equal to the change in charge. Okay, or in other words, how much charge is flowing. Okay, let's call it the flow of charge. So flow of charge. So they say that change in Q or change in charge, or in other words, the flow of charge, okay, or the amount of charge that flows through a certain piece of the wire in a certain amount of time, over the change in time, okay. So the current that is flowing through a wire is basically how much charge is flowing through the wire in a given amount of time, okay. That's current, okay. So this equation isn't really what we use to calculate the current in a circuit. We'll get to that in a second. It's what we call Ohm's Law. Okay, but this is the conceptual idea. Okay, so we still use it for certain applications, but this is more of a conceptual idea of what current is. It's the flow of charge in a given amount of time. Okay, so let's think about units for a second. Okay, so if you remember from the electricity and magnetism unit, charge is represented or is measured in units of coulombs, which is capital C. Okay, so a coulomb is an amount of charge, right? So then time is always measured in seconds, so we have coulombs over seconds. Okay, now this is named after the guy who kind of first studied this, but we call those units amps. Okay, so coulombs per second is amps. Okay, named after Ampere, who was the guy who kind of started all this. Okay, but a coulomb per second is an amp, and you probably have heard that word before when you're hooking up a stereo or something. It tells you how many amps it is, or some type of electronic device or a kitchen appliance, a certain amp microwave. Okay, but that's what it is. It's a coulomb per second. Now keep in mind, most electronics we used are in the milliamps or microamps range. Okay, 1 amp through your body probably will kill you. Okay, so you won't see things that electrically charged, right? You won't see a wire with that much flow through it. Okay, this is why we usually measure in terms of milliamps when we're talking about actual circuits. Okay, so something to keep in mind. Okay, so let's just try an example problem. Okay, so wire carries 3 coulombs of charge in 40 seconds. What is the current on the wire? Okay, so current is equal to the change in charge over the change in time, right? And in this case, okay, 3 coulombs is our change in Q, and 40 seconds is our change in time. Okay, so that makes this really easy. We just say, okay, well, change in charge is 3 coulombs, change in time is 40 seconds, so that is equal to 3 over 40 coulombs per second. Okay, and we put that into our calculator, and we get that that's equivalent to 0.075 coulombs per second, or amps. Okay. Now again, usually you won't see people write things in terms of amps, so let's report this in terms of milliamps, so move the decimal over 3 times. So this would be a 75 milliamp circuit. Okay, and even that's kind of high. That would give you a nice good sting. Okay, if you were to touch that circuit. Okay, so that'd be 75 milliamps of current. Okay? Alrighty, let's try another one. Go ahead and try this one on your own. Okay, so a wire has a current of 2.0 milliamps. How much charge will flow in 5.0 seconds? Okay, so again, pause for a second, see if you can figure this out. Alright, so if you go through this, let's first of all identify what we know. We know that the current is 2.0 milliamps. Okay, But before we work with it, we want to put it into actual amps, okay, to do the calculations. So that's the same as 0.0020 amps, okay, move the decimal 3 places, right? And then the change in time is 5 seconds. So change in t equals 5 seconds, okay? So now we're trying to solve for change in q. So if we write our equation, I equals change in q over change in t. If we're trying to solve for this guy, we're going to want to times that change in t over to the other side. Okay, so we're going to say I times the change in t equals the change in q. Okay. So we plug in the 0.0020 amps, times it by the change in t, which is 5 seconds, and that will give us change in q. So when we put that in on our calculator, 0.002 times 5, okay, we get that this is, the change in q is 0.01 coulombs. Okay? So there we go. That's how much charge would have to flow through that wire in order to get a current of 2 milliamps. Okay? Alrighty, so again, this is mostly a conceptual calculation. It's not really how we measure current in a circuit. Okay? We have to do a slightly different calculation to actually get the charge flow and the current and things like that. Okay? It's hard to measure that directly. And so the person that was the first to actually make a practical calculation was this man named George Ohm. And yes, that is the correct spelling. I double checked it, okay? Don't ask me why it is that way. But he has kind of a cool story. So he was actually a German high school teacher, I believe it was, okay? And so he was basically a science teacher, I presume, okay? But interesting enough, he just kind of did circuit stuff on the side, and he actually discovered Ohm's Law while he was just analyzing one of his circuits that he had personally constructed. Okay, so he was just a teacher, and just on the side, he was just doing research stuff, and he discovered Ohm's Law, which is one of the most fundamental laws in like electrical engineering and stuff like that. Okay, but it's a really cool way to figure out the current in a circuit without having to measure charges and things like that. Okay, you can just measure a few properties and you can get the current. Okay, but Ohm's Law is stated like this. Okay, so the voltage in a circuit, okay, is equal to the current in the circuit times the resistance in the circuit. Okay, so voltage, which we talked about a little bit in the electricity unit, is equal to the current in the circuit times the resistance in the circuit. Okay. And this is also why we talked about resistance so much last time, because it's not so much the resistors itself that are hugely important, but it's being able to calculate this total resistance to figure out the current and the voltage and things like that. Okay. So using Ohm's Law, it becomes really simple. If you want to find the current, all you have to do is take the voltage divided by the resistance, and that's your current. Okay. Voltage and resistance are very easy to find, and you just use those and you get your current. Okay. So a lot easier than measuring like individual charges or something like that to try and get the current. Okay. But hugely fundamental law, very simple though, very easy to work with. Okay, so voltage equals current times resistance. Okay. Alrighty, so let's try just a simple problem. Okay, so a circuit has 3.5 milliamps going through it, and it has a 10 kilo ohm resistor. What is the voltage of the power source? Okay, or basically what's the voltage on the circuit? Okay. So we just identify, okay, well this guy right here is our current. Okay, so in this case we know the current and we know the resistance, okay? But let's convert both of these into regular SI units, okay, before we start. So the current is equal to 0.35 milliamps or 0.0035 milliamps, or amps I mean. And then the resistance is 10 kilo ohms, or 10,000 ohms. Okay. So now we just say, well, voltage equals IR. So we just got to times those guys together. Okay, so the voltage equals 0.0035 times 10,000. And that gives us, when we put it on the calculator, that this was a 35 volt power source. Okay, which is pretty high. But there you go. So that's 35 volts across that circuit. Okay. So again, if we had an actual physical circuit like we were using in class, that would mean that to get the 3.5 milliamps across that resistance, we'd have to turn the DC power source to 35 volts, which we won't ever do in class because that's really dangerous, but you get the idea. We could, adjust the power source to get the right current going through the circuit. Okay. Let's do a slightly different problem. So we have a 1.5 volt battery, okay, like a AA battery, okay, and it's hooked up to a circuit with 100 ohm resistance. What will be the current through the circuit? Okay, so in this case, we know the voltage, okay, and we know the resistance, R, right? So what we do is we say, well, we have voltage is 1.5 volts, resistance is 100 ohms. So we're trying to find the current. Okay, so if V equals IR, and we're solving for current, we're just going to take the R, divide it over there, and we get V over R equals I, or the current. So in this case, V over R is 1.5 over 100, okay? Or, let's see, that'd be 0.015 amps, right? Let me just double check and make sure I'm thinking about that right. Yep, so 0.015 amps. But again, we don't usually report our answers in amps because that's too high of a unit, so we would rewrite this as 15 milliamps. Okay? And there you go. So that's our current through this circuit is a 15 milliamp current. Okay? All right, let's do one more just to make sure we got this down. Okay? Let's say this is our actual circuit, okay? So we have this circuit that we built in class. It's got 12 volts across the circuit, and it has a resistance of 750 ohms with the resistor and the load on it, okay? So what would the current be? Go ahead and try this on your own really quick to make sure you got it down, okay? But if you do it right, you should get after you rewrite the equation, that you have V over R, okay, equals I, right? So that would be 12 volts over 750 ohms. And so that is 0.016, okay, so very close to the same answer, 0.016 amps, okay? Or in other words, again, we wanted milliamps, so this is 16 milliamps. Okay? But there you go. So again, a very hugely fundamental equation in circuits and electrical engineering, that type of stuff. Okay? Being able to calculate how much current's going through the circuit so that you can design it properly so you're not going to blow things up, but things still work, and that type of thing. Okay? So you're going to want to make sure you're very comfortable with this equation and how to use it. Okay? Next time in class, we'll look at how we actually use devices to measure things like the voltage or the current if we need to, and how they use Ohm's law to determine these things. Okay? But other than that, just make sure you get started on the homework. And just let me know if you have any questions, but hopefully that made sense, and thank you for watching.